acceleration of a particle from rest is given by A. A stands for acceleration, equal to 10 minus 3t. T is for time. Find the A, velocity after 2 seconds, B, acceleration after 2 seconds, and then finally C, the distance from the starting point to where it is momentarily at rest. So we want to start here. How do we calculate velocity? Because we have acceleration. So once we are at acceleration, for us to calculate velocity, we integrate acceleration. So let us integrate acceleration and we will get velocity. So to get velocity equal to, this is the sign for integration. We are integrating 10 minus 3t. So let us integrate that. And then we put bracket dt. When we integrate, we put like that. So you should always remember that at rest t is equal to 0 and the velocity is equal to 0. When a particle is at rest, nothing is happening. So let us integrate this. I hope you know how to integrate. So because it dt, so we are going to here we are going to have 10 t. So velocity is equal to 10t. We add t here minus 3 t plus what it is. This t is raised to power 1, so we add 1, that is 2, and then we divide it by the power 2, right? After that one, but we are asked you to find the velocity after 2 seconds, that is time. So when t, or after 2 seconds, what will be the velocity? So where we have t, we substitute with 2. So velocity is equal to 10 times 2 minus 3 into 2 raised to power 2 divided by 2. So velocity here equal to, this is 20 minus 412 divided by this, that is 6. And that velocity is equal to 14 meters per second. Acceleration. Find acceleration after 2 seconds. So we have already acceleration. So we know that acceleration is equal to 10 minus 3t. So after 2 seconds, we just substitute, because this is time. 2 seconds is t. So we substitute t in the acceleration and we get the acceleration when time is 2 seconds. So that is 10 minus 3 into 2, and that is 10 minus 6, which will give us 4 meters per second square, because acceleration, this is the SI unit of acceleration, meter square. Find the distance from the starting point to where it is momentarily at rest. So we are calculating a distance, but remember, distance equal to when you integrate velocity. For you to get the distance, you integrate velocity. So distance is given by s. We usually use s standing for distance. So distance is equal to integration of velocity, but we have velocity. Do we have velocity? Yes, we have velocity. Our velocity is t minus this. So we are integrating 10t minus 3t square over 2 d. Therefore, s equal to, now let us integrate this one. This is 10t. This t is raised to power 1. So we add 1 divided by 2. See, this one is going to give us 10 t 1 plus 1, which is square, divided by the square 2, minus, this is 3, this is 2, so 2 plus 1 is 3, divided by 2 times 3, it's going to give us 6, right? So this one is this way I want here. So we have 5t square minus this one's here twice, t3 divided by 2, and this is distance. But we know that the particle is momentarily at rest when velocity equal to 0. If it is at rest, velocity is equal to 0. And what else is at 0? So our velocity here, the velocity which is 10t minus 3t squared divided by 2, this one we equate it to 0 because at rest velocity is 0. We want time here. So this one will give us 10t equal to, this one equal to this side, 3t squared divided by 2. So we want to eliminate this 2 from here. We multiply times 2 times 2, so we will have 20t equal to 3t squared. So we can divide by both sides by 3. So divided by t, we will have 20 equal to 3t. So divide by 3, divide by 3. So t equal to 20 divided by 3. Now we have time when the particle is momentarily at rest. Time would be 20 over this. Now we take this time and substitute to our distance. So s equal to 5. Instead of t squared, now we are going to put 20 over 3 raised to power 2 minus. Instead of t cube, we are going to have 20 over 3 raised to power 3 divided by 2. This one will give us 2 over 3 minus 148, 4 over 27. And this one will give us 74, 4 over 27, and that is in meters. And that is the distance from the starting point to where the particle is momentarily at rest.